Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 3 Chemistry class. How are you? Hope you are very fine. I'm Scovia, your chemistry teacher, as always. Today we are starting Unit 1, that is carbon and its inorganic compounds, right? Carbon and its inorganic compounds. So under this, we are starting with lesson 1, which is allotropic forms of carbon and their physical properties. Allotropic forms of carbon and their properties. So we are starting a unit which is carbon and its inorganic compounds. So we start by looking what we call allotropic forms of carbon and their properties. So at the end of the lesson, the objective we have today for this lesson that every learner, by the time we finish this lesson, will be able to name the allotropic forms of carbon and relate them to their properties and uses. All right? You name the allotropic forms of carbon and relate its properties to its uses. Get that? So that is the objective of the lesson today. You need to know what carbon is. You need to know the allotropic forms of carbon. First of all, you shall know what the term allotrope means. So you will know the allotropic forms of carbon and relate them with their properties. Is that clear? You name the allotropic forms of carbon and relate its properties to their uses. That is the objective of today's lesson. I hope everybody is attentive and prepared with a pen and a book, and we start off with the lesson, all right? Hope you understand what we are saying, and you're ready to start the lesson. Good. So let's start today's lesson. So by introduction, carbon. In Senior 1, you studied about elements of the periodic table, all right? Elements of the periodic table. Among them, you found carbon. Get that? Carbon is also among the elements in the periodic table. So we're going to look at carbon and its allotrope, or carbon behaving in forms of allotrope. So we said that carbon is the most common important element among the elements of the periodic table. So it exists both naturally as diamond and graphite, but also it exists in other forms, combined forms. Naturally, we have carbon as diamond and graphite. You will know this and how. And then we have carbon in a combined form, all right? That is coal, carbon in the form of coal, oil, natural gas, limestone and other metal carbonates, and then charcoal. Charcoal also is a form of carbon, all right? So what is the term allotrope? We are talking about allotropic form of carbon. So what is allotrope, class? What is allotrope? Allotrope is the existence of an element in two or more than two forms. You get that? The existence of an element in two or more than two forms. That is allotrope. The term allotrope means the existence of an element in two or more than two forms. You get that? So elements that exhibit allotrope, we have other elements apart from carbon. We have sulfur and phosphorus. They also exhibit in forms of allotrope. So allotrope have some chemical properties, same chemical properties, but different physical properties. So when we talk of the allotrope or elements behaving in the form of allotrope, we said that allotrope have the same chemical properties, but the physical properties are different. That's why we are going to put emphasis here on some of the physical properties of these elements or the allotrope of carbon. All right? Good. So I think everybody has picked what the word allotrope is. Allotrope is the existence of an element in two or more than one form. So you find some elements exist in one form, but for the case of those that exist in two or more than two forms, we call them allotropic. Among them, we have said we have carbon, we have sulfur, and we have phosphorus. All right? So we are saying that allotropic, they have the same chemical properties, but they have different physical properties. So under this topic, as we have seen in our objective, we are going to look at those forms of carbons, those different forms of carbons. We look at their physical properties and relate them with their uses. All right? Good. Hope everybody has understood the word allotropic. So we can continue from there. So the physical properties of carbon allotropic and their uses. The physical properties of carbon allotropes and their uses. Remember that allotropes have got the same chemical properties, but they have different physical the physical appearance, the physical properties are different. So the allotropes have these allotropes of carbon. There are in two forms. You have those we call crystalline form and those we call non-crystalline form. All right? We have the crystalline form and the non-crystalline form. What are crystalline forms of carbon and what are non-crystalline forms of carbon? Crystalline forms of carbon and non-crystalline forms of carbon. So the crystalline forms of carbon are those kind of carbon, allotropes of carbon, that have got shape, a designed shape, a known shape. But when you talk of non-crystalline forms of carbon, there are amorphous. What is the term amorphous? They are shapeless. You can't tell their shape. You can't say they are regular, they are hexagonal, they are what? You can't tell their shape. So we have two kinds of allotropes of carbon, the crystalline forms and the non-crystalline forms. The crystalline forms are those that have got shape. And non-crystalline, they are called, another term is amorphous carbon. In other words, they are shapeless. If you tell the word amorphous in English, it is, when we talk of the word amorphous, we mean something which is shapeless. It has no shape, all right? So something that does not have a designed shape, call it amorphous. So amorphous carbon, there are carbons that have no shape. You can't tell they are of this shape. So in other words, they are non-crystalline forms of carbon, all right? So we are starting by looking at those which are crystalline, all right? Look at the slide. Because before you go far, under the crystalline forms, we talked of the diamond and graphite. Diamond and graphite, all right? Diamond and graphite. Those are crystalline forms of carbon, the one with shapes. So we are starting by looking at those. So this is the structure of diamond. We are starting by looking at the structure of diamond. All right? Because we have said that their structure has a form, a designed form, a known shape. All right? So in diamond, each carbon, so these things you see which are kind of zero kind, these ones you see here, these ones you see, they are representing carbon, all right? So they are saying in a diamond, each carbon atom is covalently bonded to 4 other carbon atoms. One carbon is covalently bonded to 4 other carbons. You know, normally, when a carbon is bonded to 4 other carbons, it gives it what we call a regular tetrahedral shape. That one is a tetrahedral shape, all right? This results, because the carbons are bonded to 4 other carbons, it means that it is strongly, closely or linked or closely shaped. It's very hard. So the atoms form what we call a giant structure. All the 4 valence electrons in diamond are used in bonding. You know what we call electrons. So all the 4 electrons in diamond are bonded. They are used in bonding, which gives it which contributes to its physical properties, as we're going to see. So in brief, when we look at the structure of diamond here, we have to note that all the 4 carbons are bonded to, each carbon is bonded 4 other carbons by what we call covalent bonding. You know covalent bonding in senior 1, and senior 2, sorry, started that. It is bonded to 4 other carbons. So that one gives it a shape we call a regular tetrahedral shape. All right? So all the 4 electrons that are used in bonding. So this one will contribute to the physical properties we are going to see down here. The electrons being bonded, the 4 electrons being bonded, it gives it its physical properties, as we are going to see, all right? So what are the physical properties of diamond? 1, diamond is the hardest known natural occurring substance. Why do you think so? We are saying that diamond is the hardest known natural occurring substance. This is because we have said that the structure of diamond, or the physical makeup of diamond, the 4 carbons, all the 4 carbons are bonded together by a strong covalent bond. So it gives its shape to become the hardest substance in nature. All right? Another thing, a diamond, when you happen to cut it, it is colorless and transparent with this dosing brilliant luster. All right? So it is colorless. So, so this one is brought by the refractive index, the high refractive index it has in it. All right? So another physical property is diamond has the higher density of around 3.5 grams per cubic centimeter compared to that of graphite, which is 2.25 grams per cubic centimeter. So you see the density of diamond is a bit higher compared to the density of this graphite. That one is brought by the arrangement of atoms in diamond crystal, which allows for more atoms to be packed in a given space compared to that of graphite. So another property is that diamond has got a high melting point and boiling point. So it melts to around 4,200 degrees Celsius. This is because all the carbon atoms are bonded by very strong covalent bonds that require a lot of heat to be broken down. What does this explains? Class, this means that because in the structure of diamond, we have said that each carbon is bonded to other 4 carbons by a strong covalent bond. So this one makes diamond to be the hardest substance, whereby to break the bond, when you're heating or melting this diamond, it needs a high temperature. Because it is very strong, it needs, because of this strong covalent bond that joins each carbon with another carbon, it needs high temperature to break the bond between carbon and carbon. So this temperature of 4,200 degrees Celsius, imagine you can compare with water. Water boils at only 100 degrees Celsius. Now multiply it to get 4,200. So if you happen to touch in boiling water, how hot it is. Now multiply it to get 4,200 class. It is a very, very high temperature. So this is brought about the hardest or the hardness of diamond. All right? So diamond does not conduct electricity. Another property of diamond. Why do you think it does not conduct electricity? Remember we said in the beginning on the structure of diamond, we had said that diamond has got 4 electrons all involved in the bonding. All right? All the 4 electrons, electrons are the ones that help in conducting electricity. So we have said that all the electrons are bonded. So if they are used in bonding, and there is no free electron. Call it delocalized electron. When we say delocalized electron class, we mean free electron. There is no movement of electron, and when there is no movement of electron, there is no conduction of electricity. I think that one is clear to everybody, because the free electrons, they are the ones that helps in the conduction of electricity. Therefore, since diamond or the 4 electrons are used in the bonding, there is no free electron. It gives it, it disables this diamond not to conduct electricity, since all the electrons are used in bonding. So diamond does not conduct electricity. We are going to see it is the opposite of graphite. Since we are going to see in graphite that it's only the 3 carbons that are bonded, and there is one remaining which is not bonded, we shall see there is a free electron which helps in the conduction of electricity, and we shall say that graphite conducts electricity while diamond does not conduct electricity, since it does not have free or delocalized electron. All right? Another thing is that diamond is a good conductor of heat because of its strong covalent bonding. Yeah, we have said that this diamond have got all the 4 carbons bonded, all right? All 4 carbons bonded, and it is the hardest substance. So it's a good conductor of electricity because of this strong covalent bond. All right? So we are done with the physical properties of diamond. So how are these physical properties of diamond? Rate them with their uses as our objective. All right? How to relate these physical properties of diamond with their uses. Remember, the objective is to name the allotropes of carbon. Then from there, you relate their physical properties with their uses. All right? 1, because of its hardness. Because of its hardness, it is used for making drill tips used when drilling or cutting metals. You know how hard the metal is. All right? You know how hard the metal is. Not everything can cut a metal. But because this hardness of diamond, given by the strong covalent bond that joins the carbon with the carbon, diamond is the hardest substance and can be used in drilling or in cutting metals. So you see how we relate the physical properties with the uses. It is very hard. What does it help us? It helps it in cutting these, or used in cutting or making drills, tips in drilling or cutting of metals. All right, so we are relating the physical properties with their uses. So in other words, it is the diamond that we use in cutting grasses. So you always see when you go to buy, your parents go to buy grasses, there is a way they cut them. That thing that they use to cut, there is a diamond. So diamond is used in cutting glasses, all right? Another function or another use of diamond is used in making jewel. It's beautiful, sparkling. So we have said that diamond is giving a shiny, or it is very beautiful, or it gives that kind of shiny color. So what does it help? It helps in making jewel. So you see these jewels that female put on, some are made of diamond because of that reflection that diamond gives. Remember, among the properties of diamond, there is where we said that a diamond is a colorless crystalline and a transparent with a dazzling brilliant luster. All right? This is caused by high reflective index. So when we relate this property with the function of making the jewel, you see that due to this being transparent, being beautiful, that reflection that gives it that beautiful kind, it makes it to be used in making jewel. All right? So in brief, when you look at the objective of today, we have said that by the end of this lesson, every learner will be able to name the allotropic forms of carbon and relate its properties to its uses. That's what we have been doing. We have been talking of diamond being, we have just started with diamond. We have been talking of diamond being the hardest substance. What does it help? That is a physical property. What does it help it? It helps it in being used in cutting glass. All right? When you go to buy glass, you find there is that small thing they use for cutting glass. It is made of diamond. Because metals are very hard themselves. They are very hard. You can't cut them using anything. Not so, class? You can't bring a pang and you try to cut a metal. It can't be. So metals are hard themselves. So they need to be cut by something which is harder than them. That is diamond. All right? So the physical property of diamond being hard due to the structure of diamond, as we have said in the, as you see here in the structure of diamond, where we said that each carbon, all right, each carbon is bonded to 4 other carbons. All right? 4 other carbons, giving it a tetrahedral shape. This gives it to be a very hard thing because of that strong covalent bond between one carbon and the other carbon. Therefore, we use that diamond for cutting glass. Another thing, the property and the use, as we have said, class, we have said that it is used as making jewel because of that beauty it has due to its refractive index it has in it. All right? Another thing, among the uses, we said it is used in drilling, making some small holes. If you want to make some small holes in the hard thing, in a glass or cutting in metals, you use also diamond. All right? Good. So hope we are together. And I think by now, if you asked about diamond, you can tell a lot about diamond. You can talk of the structure of diamond. You can talk of diamond being, as a bad conductor of electricity, and you explain why. You explain why diamond is a bad conductor of electricity, because we have said, who can remind us? Why have we said that diamond is a bad conductor of electricity? You have been following. I've said diamond is a bad conductor. Among the properties here, I've said diamond is not a good conductor of electricity. Diamond does not conduct electricity. So what reason have we given? Yeah, because all the 4 electrons are bonded, are used in bonding. And remember, in the conduction of electricity, we need to have free or delocalized electron. These are very important things you need to know on diamond. In electricity conduction, there should be free electron, moving electron, delocalized electron. Those are the terms we use, all right? So if there are no free electrons, it means that that substance cannot conduct electricity. So for the case of diamond, all the 4 electrons are used in bonding, therefore no free, no delocalized, no movement of electrons. You get me? Therefore, it is a poor conductor of electricity. So you need to take that, because that one is very important for you. So I think everybody now can tell the properties of diamond, describe the structure of diamond, the uses of a diamond. You relate the physical properties of diamond with the use of diamond, because it is from the physical makeup or the physical properties of diamond that you get the uses or the use of diamond. All right? That is clear to everybody. Good. So from there, we can do this small exercise here. As our objective, or as we had started, we are talking of the word allotrope. So you need to tell me or to remind us or to remind yourself about the structure. This is an exercise you're going to do in your free time. What is allotrope? You are going to name the two elements that exhibit as allotrope. So we said in the starting, remember we said that it's not only carbon that exhibit or that exist as allotrope. There are other elements in the periodic table that exist as allotrope. So you're going to mention two of them. All right? Another point, you name the allotropes of elements named in the equation give 2 above. So you name the allotropes. All right? That existence. Another thing you're going to name, question 4, you're going to name one non-crystalline form of carbon that you know. So remember when we were introducing the topic class, we said you have 2 forms of carbon. In other words, carbon exists in 2 different forms, or exists as allotrope in 2 forms. One, crystalline form and non-crystalline form. Remember, in under crystalline form, that's where we talked of diamond and carbon. And then we talked of the non-crystalline form, those which are shapeless, those which are amorphous. We named them, so you have to remind us, to remind yourself. Only one among the many we have talked about. You name one non-crystalline form of carbon that you know, those which are shapeless, those which are amorphous carbons. All right? Another thing you have to explain why diamond is not a good conductor of electricity. I've insisted on this when I've been explaining. Why is it that diamond is not a good conductor of electricity? All right? So I think this work will be easier for you because we have discussed together all the questions that are there. We have discussed them together. So you need to sit down and read back what we have talked about. Then you try to answer the questions that I've put up. All right? So thank you so much for your good attention. You have been good students. You have followed very well. And I think the exercise is going to be very easy for you because you have been very attentive. Thank you so much for your good attention. Let's meet in the next lesson. Bye.